Hello guys, welcome to another video, and in this video we are going to be configuring IPsec between a firewall and a router. So between this firewall over here and this router over here, we are going to be configuring IPsec, site-to-site IPsec, not remote VPN. It's going to be a site-to-site VPN because with IPsec you can either do a site-to-site or a remote access VPN. Not like SSL. SSL only lets you do a remote access VPN. So let's go ahead and configure this. And we're actually going to be configuring IKEv1. Then we're going to remove it, and then we're going to configure IKEv2 as well. So we're going to test both of them so you guys can see how to configure both of them. The first thing that I want to do, hopefully you can see the IP addresses. For the website over here has 172.16.50.2. This ASA on IKEV1 has .50.1. And then on the outside is 10.10.10.200. This one router over here on the outside has 10.10.10.6, and the inside 10.6.6.1, and this browser over here 10.6.6.2. Hopefully you guys are able to see it from this video. So the first thing that I want to do is I want to see if I'm able to ping from this ASA. I want to see if I'm able to ping the router, and as you can see I'm able to ping the router, so that's good. Something you want to do before. After we do that, I want to go ahead and create an object, and it's going to be called network, and we are going to call it inside network. This is going to be the inside network of the ASA, so this one over here. And I'm going to say this one is going to be this one is a subnet of 172.16.50.0, and it's not going to be a wildcard mask, but it's going to be a /24. Alright, then we are going to create another object, and this object is going to be called network. It's going to be a network object, and it's going to be called the router1 R1 network, and I'm going to add the inside network of router1, which is 10.6.6.0. we do a subnet, and it is 10.6.6.0/24. Then we're going to do an exit out of here, and then after that I want to create a access list, and I want to call this let's just call it cry ACL. And here what I want to do is I want to permit an IP address object, and I want to permit the object of inside network, which is going to be the source, right? And the source going to this other network over here, which is the destination. So R1 network. So inside network does not exist. Oh, I just put inside net. Let's go ahead and edit that. There we go. So what I'm doing right here is I'm creating an access list, and I want to permit an IP address, or any IP address coming from this object, which is the inside. This is the source, which is this network. So any traffic coming from this source going to router1 network, which is 10.6.6.0, this one right here. Okay, so I'm permitting that access, and that access list we are going to be using it for the crypto map and all that. So after we do that, we also need to do a route outside, and we need to tell it where to go whenever they want to reach 6.6.6.0/24. I want you to send it to 10.10.10.6. There we go. And if we do a show route, you should see a static route. And what I'm saying is, if anybody from the inside, or if anybody wants to go to 10.6.6.0, please send it to 10.10.10.6, which is router1, and it should be able to get to that. Okay, good. So now what we want to do is we want to create the crypto, not ISAKMP, IKEV1 policy, and in this policy, policy 1. And over here we want to specify the hashing algorithm that we want to use. We want to use MD5. The authentication that we want to use is a pre-share key. The group number that we want to use is 2. Lifetime, so we're going to set it to the default, which is 86 and 400. Then we want to do encryption, which is going to be 3 des. Good. So after that is done, let's just go ahead and exit out of here, and we want to do a crypto IKEv1, and we want to enable it to the outside interface, which is this one right here. Okay. So after that is done, let's go ahead and create the IKEv2 policy, because we are going to, like I said before, we are going to be configuring IKEv1 and also IKEv2. So we're going to configure IKEv1 first and test it, and then we're going to configure IKEv2 and test it. So let's go ahead and create the IKEv2 policy. So you do a crypto IKEv2 policy number 1. We're going to do a encryption, and it's going to have a encryption, and it's going to have AES 192 and then AES. We also want to do integrity, and integrity for this is going to be SHA 256 and SHA. So as you can see, for IKEv2 you are able to select 2. So either use this one, if the other one does not have that one, then use this one. For also integrity, use, or for hashing, use SHA 256, and if it doesn't have SHA 256, then use just regular SHA. And that is a benefit that IKEv2 has over IKEv1. IKEv1, if you want to do the same, you will have to create another group policy for that. But for IKEv2, you can only create one group policy and add as many options as you want for integrity, encryption, and all that. And also group, we are going to do either 5 or 2. Lifetime, we are going to leave it at the default 86,400. Actually, we need to put seconds 86,400. And then we're going to exit, and we also need to do a crypto IKEv2 enable to the outside interface, which is this one right here. Okay, so that is done. Let's go ahead and do the IKEv1 the IKEv1 transform set. So let's go ahead and do a crypto IKEv1, or actually, yeah, crypto is going to be IPsec IKEv1 transform set, and this one is going to be called tset. And we're going to use ESP AES, then ESP SHA with HMAC. Done. And then if you're going to be using, let's go ahead and just set the transfer set for IKEv2 as well. Actually, we're not going to do that now. Let's go ahead and just leave it like this, and let's go ahead and just do the IKEv2. So let's go ahead and do crypto IPsec IKEv2, and this one is going to be the IPsec proposal, and we're going to be call this IPsec v2 AES. That's going to be the name of it. And after that, we want to do a protocol ESP encryption AES, and then the protocol integrity integrity. Why is it not taking it? Let's go ahead and do, let's see, we are at the crypto IPsec IKEv2 IPsec proposal. Let's go ahead and do a question mark. Okay, it doesn't let me do integrity or group number for the IKEv2 proposal. It only lets me do the ESP IPsec. Okay, so let's go ahead and leave it like that. Exit. Let's go ahead and do the group policy. And we're going to call this group A, and it's going to be internal. Then we want to do a group policy. We're going to select the same group A that we just created, and we're going to add some attributes to it. And inside this attribute, we just want to do a VPN tunnel protocol IKEV1, also IKEV2, so we can use both. So what I'm saying is, for this group policy that we created group A, I want to add some attributes, and the attributes is that we want to turn on the VPN protocol of IKEv1 and also IKEv2. Then we want to do a tunnel group, and we're going to say it's 10.10.10.6, which is the IP address of router 1 over here. Tunnel group type IPsec 1.2. Let's go ahead and just do an exit. Tunnel group 10.10.10.6 type and for this one, it's IPsec LAN to LAN. There we go. Okay, so it needs to be an L to L. That's what I was missing. Okay, so from this tunnel group, you want to do an IKE. Let me see. Okay, we did the tunnel group. Then we want to do a tunnel group 10.10.10.6. And we're going to do general attributes, and we're going to say that the default group policy that we're going to use is going to be the group A that we just created. We're going to exit out of here. Then we're going to go again to tunnel group 10.10.10.6. And we want to do the IPsec attributes. And inside right here, we want to do the IKEV1. We want to add the pre-share key, which is going to be called Cisco. So that's the pre-share key that we're going to be using. And then for IKEV2, local authentication is going to be a pre-share key, and it's also going to be Cisco. Actually, let's leave it like that. Then let's go ahead and do the remote, which is also going to be the same. Okay, so then we can do exit out of here, and then after that, let's just go ahead and do a crypto, and we're going to create this IKEV. Let's just go ahead and get not IKEV1. Let's go ahead and call it crypto our map. We're going to match crypto our map 1. We want it crypto map our map, and this one needs to be 1. We want to match, and we want to match the address from cry ACL. Then we do a crypto our map 1, set the peer to be 10.10.10.6. Then we're going to do a crypto our map set IKEV1 transform set to tset. Then we do a our map again, and we need to do the IKEV2 set IKEV2 so it's a set. Let me verify that. Set IKEV2 IPsec proposal, and then on this proposal we need to add that proposal that we created. I forgot the name of it. Let's go ahead and go into that proposal we call IPsec v2 AES. Let's go ahead and paste it right here. There we go. And then we need to go ahead and set that crypto map our map interface outside interface. So now we are ready to form a VPN either with IKEV1 or with IKEv2. So let's go ahead and create that from router 1. Config G. And from over here, the first thing that I need to do is do a crypto. Crypto. The IKEv1 policy, which is ISAKMP. It's not IKEv1. IKEv1 is only for the firewall. From the router 1, you need to do the ISAKMP policy, which is the same as IKEv1. And from over here, we need to match everything we did. Hash was MD5. Authentication was pre-share key. Encryption was 3 des. Lifetime was 86,400. Group number was 2. Okay, good. After that, let's just go ahead and do a crypto. We do a crypto ISAKMP. Actually, let's go ahead and exit and do a crypto ISAKMP. Key is going to be Cisco. The IP address of it is going to be 10.10.10.200 because we're going to point this from this router to the ASA, which is 10.10.10.200. Okay. Then let's go ahead and do the crypto IPsec transform set. We are going to be called this T set. And after that, let's go ahead and do ESP AES. It needs to match from like the other side, which we set SHA with HMAC. Exit. Then let's go ahead and create that IP access list. It's going to be an extended access list. We're going to call it the same name. Doesn't really need to match. And we want to permit 10.6.6.0. This one to be a walker mask. And we want to permit to the destination of 16.15.0.255. Permits IP. There we go. Exit. Then we want to create a crypto map. Let's just call it IKEv1 map for this one. Want IPsec ISAKMP. Right here we need to match the address of cry ACL. Then we need to set the peer to the IP address of the ASA or the firewall. Then we want to set the transform sets to T set. After that is done, let's go ahead and go to interface gigabyte00. Do a crypto map IKEv1 map. There we go. ISAKMP is now on. So let's go ahead and end it. So crypto ISAKMP SA. So we don't have any SAs right now because we have not sent any traffic. But after we send traffic, we should be able to do that. So let's go ahead and do a ping to 172.16.50.2. And we are going to source this from 10.6.6.2. Let's see. It's 10.6.6.1. There we go. And we don't have any traffic. That's because we need to do a config T to IP route to 172.16.50.0. I wanted to send it to 10.10.10.200. And let's go ahead and ping again. Let's go ahead and ping again so you can see it. There we go. We were able to ping. Now let's go ahead and do the show crypto ISAKMP SA. And you can see now that we have that crypto ISAKMP SA. We should be able to see the crypto SA. You can see it right there. All the packets that we have sent, 9. And if you want to do a source and then repeat it 100 times, you should see now that it went up by 100 times. So that it's working. Also, if you want to do a crypto ISAKMP SA details, you can see that all the details. You see more details over here. Also, if you want to do a crypto or show crypto sessions. You can see that over here. Also show crypto engine connections active. You see the active connections that we have right here and all the traffic that we have sent. So the counters are there. Okay. So that is good. That is working. So now, since that is working, what I want to do is let's go ahead and remove that from over here. So we do no crypto map IKEV1 map, so we can remove it. And after we remove it, since we saw that IKE version 1 was working, let's go ahead and configure IKEv2 and see if it works. So let's go ahead and do a crypto IKEv2 proposal. We are going to be calling this IKEv2 proposal. And inside right here, we need to do the encryption, which is AES CBC 128. Then we do the integrity SHA-1. Group number, we want to do either 5 or 2. And that's it. We exit. Then we want to go into crypto IKEv2 policy into the default. And we want to set that proposal that we just created, the IKEv2 proposal. Copy and paste it right here. After that is done, we need to go ahead and configure the crypto IKEv2 keyring. We are going to call this IKEv2 keyring. And inside of here, we need to set the peer to be AES1. The address of it is going to be 10.10.10.200. The identity address is the same. Then we do the pre-share key, local Cisco, pre-share key, remote Cisco, exit. Now let's go ahead and create the crypto. Go ahead and exit again. Oops. Exit, do the crypto, IKEv2 profile. We're going to record this IKEv2 profile. And inside this IKEv2 profile, we need to do a match match address local 10.10.10.6, the local IP address of the router 1. Then we do the match identity remote address 10.10.10.200 for the ASA, the authentication that we're going to be using. For the local, it's going to be pre-share key. The authentication for the remote is also going to be using pre-share key. Then we need to go ahead and attach the keyring that we created, IKEv2 keyring. Now let's go ahead and do the crypto IKEv2 transform set. We're going to name this T set. We're going to be using ESP AES and ESP SHA with HMAC. C crypto IPsec. Let's go to and exit. Then after that is done, we need to go ahead and do the another access list. So let's go ahead and do IP access list extended. Let's just call it 202. We want to permit IP address coming from 6.6.6.0.255 to the destination of 172.16.50.0/24. We can go ahead and exit out of here, and then let's create another crypto map, and this one is going to be called IKEv2 map. IKEv2 map 1 IPsec ISAKMP, and inside right here we need to match the address of 192 or 102, which is the access list that we created, that is going to permit the source going to the destination over here. Then we did set the peer to 10.10.10.10.200. Set transform set to tset. Set IKEv2 profile, which was set to IKEv2 profile. Good, so that's done. We are done. So let's go ahead and go into interface IKEv0, do the crypto map IKEv2 map. You can see ISAKMP is now on. Let's go ahead and end this show crypto IKEv2 SA. We don't have any right now. So let's go ahead and do a source and repeat it 100 times. There we go. So crypto IKEv2 SA, and you can see right here it has formed that IKEv2 SA local remote, and it's using port 500 because we are using IPsec without NAT transversal. So we're not using NAT T. If we were using NAT T, we were going to be using port 4500 for both of them. Also, if you want to do a IPsec SA, you can see that IPsec SA, we sent 99 packets because the first one did not go through, either because of ARP or because it was establishing that IKEv2 tunnel and then that IPsec tunnel. All right, you can also do a IKEv2 SA detail. You can see more details over here. You can also do a show crypto engine connections active. You can see right here. So what else you can do? You can do a crypto or show crypto sessions. You can see the session right here. One session via IKEv2 SA using the local of 10.10.10.6, port 500 to the remote of 10.10.10.200, and it is active. And we are using that IPsec flow of permit this IP address 10.10.10.6.6.0/24 going to 72.16.50.0, which is this website over here. So it is working great. Now let's see if we are able to go ahead and open this browser and see if we are able to go into this website over here. It should also be encrypted. So 172.16.50.2. Is it gonna let me in? Yep, you can see it right here. It's saying turnkey Linux, just another WordPress website. And what that is going, you can do a show crypto IPsec SA. You can see that we have seen a lot of more traffic because we are trying to get into this website over here. That is taking a little bit, but it is transferring data right now. There we go. Refresh. There we go. And if you do a show crypto IPsec SA, you can see you have a lot of more traffic. If you refresh it, you get a lot more traffic. Encrypted and decrypted. And we see no errors, no receiving errors, no send errors. So it is working great. So guys, this is it for this video. And if you guys enjoy this video, if you guys like my videos, why don't you just go ahead and subscribe to my channel. Also, if you have a Twitter account, go ahead and follow me on Twitter at CCNA Daily Tips. Thank you guys for watching this video. I will see you on the next one, guys. Bye bye.